Okay, a lot to know for this test. Like a lot to know. Let's start with some easy ones. What if I just said, this polynomial has some roots. What are the possible roots for this polynomial? That's that rational root term I just taught you yesterday. It's like if we were going to do synthetic for it, what could we use? What are the possible roots? There's lots of them. All right, your first thought should have been, what are the factors of this? And that's 4 and 1. Don't forget the 1. And 2 and 2. And I'm not going to write another 2. That'd be dumb. And don't forget it's plus and minus of all of them. I will accept a plus minus at the beginning if you put the rest in parentheses, but. And then you take the factors of this and you put them down here. 2 times 1 makes 2. And plus and minus of those. And like I said, it's fine to put plus and minus in front of your big list of answers, which would be, well, each of them gets divided by 1, right? 4 divided by 1 is 4. 1 divided by 1 is 1. 2 divided by 1 is 2. And then each of them gets divided by 2. 4 divided by 2 is 2. Now, I could put another 2 in the list, but that's kind of dumb. We already know that 2 is in the list. And then 1 divided by 2 is a new one. That's 1/2. And 2 divided by 2 is 1, which is already on our list. Now, if you really are a concrete sequential, it'll drive you crazy. They're not in numerical order. But doing that is just kind of wasting your time. These are the ones that you need. You don't have to put them in numerical order. Do you get there's 8 things that could have worked as factors? 4 things, but it's plus and minus of all of them. That's 8 things. Now let's check just one of them. I'd like you to check -1 and see if it actually is a 0 of this. Hint, synthetic. Is there missing terms? Oh, yes, there is. This is really 2x to the 5th plus 0x to the 4ths plus another 0x to the 3rd plus another 0x to the 2nd. Finally, there is some x to the 1st. There's 2x to the 1st, and then there is a 4 at the end. So you should be checking 2, 0, 0, 0, 2, 4. That's called synthetic. That tests you on 3 things. Do you know how to find the roots? Do you know synthetic? And then do you know how to translate the synthetic? Like what does the answer mean? In the immortal words of Snoop Dogg, drop it like it's hot. Really what you're doing is adding down, and it's just that there's nothing there, and so then you get 2 plus 0 is 2. But it's like hard to explain all that, so I just say drop it, multiply it, add it, and you keep on adding and multiplying from here on out. Multiply, add, multiply, add, multiply, add, multiply, add. Holy crap, it worked. Anybody else get a 0 remainder? All right. I want to tell you, that was pure luck. I did not know which of the roots worked. I grabbed one. I had a 1 in, well, how many were there? There was 8. I had a 1 in 8 chance that was going to work, and it just happened to work. Okay, so now, what does it mean? Okay, so it means that -1 was a 0. But what is the factored form of your answer? Like, that gives you x plus 1. What on earth do all of these numbers mean? I like to start at the end, because 4 is just 4. It's a constant. And then the negative 2 is a negative 2x. And then the positive 2 is a 2x squared. And then the negative 2 is a negative 2x to the third. Oh my gosh, I'm barely going to make this fit. And then the very first one is a regular 2, and that's a 2x to the fourth. And I think I forgot a sign in here. If there is no sign, it must be a plus. Holy cow, that was really difficult factoring. Yes?
Can't you factor out the 2?
I love that you're thinking, can we factor it again? And you are correct. There's a 2 in everything. So you could factor that out. And I bet you it could even be factored again. Would we have anything that hard on the test? Probably not this hard. But would they factor again? Oh, definitely. Definitely they'll factor again. All right. So that covers synthetic and what's called rational root, which is like which roots could work. All right. What else is on this test? Yes, question.
So on the test, if we wrote that down, it'd be correct?
That's a good question. Is this the final answer for the test? No, because he already told us. Carter said you could factor a 2 out of everything. And if you can factor it, you should. Point on the test. It'll even say factor this all the way. It'll give you some kind of a hint that you need to factor it as further than you would think. So no, you couldn't just leave it like this because the 2 factors out.
So would we?
Do you want me to tell you what it would be?
Yeah.
Okay, x plus 1. And then your 2 really should go to the very front of everything, even though some kids would write it here, and I probably would take it. And then you'd have x to the fourth minus x to the third plus 2x. No, not 2. It's not a 2 anymore because I took the 2 out. Plus x squared minus x plus 2. And then you'd have to ask yourself, does this factor again? It's like a whole new problem. Do you get I can do the rational root on it and figure out that the factors of this are 2 and 1, and then there's only a 1 in the front at least, so like you divide by 1, but that doesn't really do anything. So basically it's either plus and minus 2 or plus and minus 1 are the things that could possibly work, and you'd have to test all of them to see if this thing factors again. But I want to stop because I don't want to spend all hour doing one problem. But the point is, you got to keep factoring as far as you can. That's the scariest, hairiest, hard problem. You want to see a really easy one that's something you have to know for your test? All right, here's a really easy one. What if I just said, this equation on the right side, is it going up or down? On the left side, is it going up or down? And what's the y-intercept? I think I know. Do you know? Talk to the kid next to you. See what you think the answers are for that one. All right, Macy, can you tell me, is it going up or down on the right? Down, that tells you it's going down on the right. Now, really all I know about the left is that it's either the same or different than that. This tells me, an odd degree tells me it's different than that. Therefore, it must be up. You with me? Okay. Last one is the y-intercept. Finish this sentence for me. The y-intercept is where x is 0. So I put a 0 here and I put a 0 here, and then y equals 7. But if I put 7 there, I'd get a mistake. It's not just 7. The y-intercept is where x is 0, comma 7. Do you have to write it that way? Yes, you do. You can't just say 7. It's too vague. Where is 7 on a two-dimensional graph? There's tons of 7s. 0, comma 7, there's only one spot. Okay. All right, next thing is, if you look at a graph, everybody sketch this graph for me. And I'm going to say that spot is at 2, comma 1. And that spot is at -3, comma -2. I could ask you so many things about this, it's ridiculous. I could say, is the lead term negative? What do you say? Is the lead term of this equation negative? Yes. Who can tell me why it's negative? Nikita.
The graph is going down on the right.
It's going down on the right. So the lead term must be negative. Good. Does it have an absolute maximum? That's the highest place of them all. Does it have one? No. Does it have a local maximum? Locally, that's the highest spot. That is called a local maximum. Does it have an absolute lowest spot called an absolute minimum? Nope. Does it have a locally lowest spot? Yes, that's called the local min. All right. Next question I could ask about this picture. So many things I could ask you. Does it have any x-intercepts? How many does it have? Oh, there's more than 2 x-intercepts. There's 3. There's 3 x-intercepts because it touches at 3 spots. I don't know what they are. It didn't tell me. But it does tell me that one because it goes through the origin. That makes a special spot. It's not only the x-intercept. Finish that sentence. It's also the y-intercept. Okay, good. So many things I can ask you about this picture. Here's another one. Was this function ever decreasing? Yes. Remember that these are intervals, and it's decreasing in 2 spots. And what do you put between 2 intervals? A little union thingy. It is decreasing in 2 zones. The green zone here, it's decreasing. Remember, you read from left to right, so it's decreasing in there. And the other place it's decreasing is in this zone. Can you tell me what goes here and here then? If you forgot increasing and decreasing intervals, you should go watch that video again. Remember, in my class, I work really hard for this. There's very few math teachers who record their lesson every single day because it's a pain in the butt. But I do it. So you can use those. You know, like if you know, oh man, I'm bad at those intervals. I always get those wrong. You can go watch the video for it. This video is probably the most popular one. It's the one you do right before the test because it sums up everything. All right. So this green zone here, if I'm talking about x values, which is what I am talking about, then it goes from -infinity, that's an x value. It's like way over there, until here, which is the x value of -3. And the other place it's decreasing is easier. To me, the ones that are on the right side are easier. It goes from 2 to, but a lot of kids say -infinity, and I totally get it, but they're totally wrong. It's an x value. It's like way over here, which is x is positive infinity. Those were the places where it was decreasing. All right. Next, you have to be able to factor in a bunch of ways. Let's do factor by grouping. X to the third plus 3x squared plus 4x plus 12. Can you factor by grouping? Do talk to that kid next to you, see what they think the factor by grouping answer is.
Oh, wait, no.
Okay, x squared comes out, and then you got x plus 3. 4 comes out, and you should put a plus there, and you get x plus 3. Coincidence that we got the same thing? Of course not. That is what's called the common factor now. So it's the common factor, and it goes out to the front. It does not have to be in front, but that's why I like to do it, because that's what you do every other time. You put the thing in front, right? I factored out an x plus 3, so I put it in front, and then I got an x squared plus 4 left. Now this brings up an important point. There's two kinds. No, wait. First of all, how many roots are there? If you never caught this in algebra, the fundamental, seems really important, theorem of algebra is that if that is a 3, you have 3 answers. There are 3 answers. You might think, well, I know one of them's -3, but I don't know what these are. Well, then you would not do well on this test because those are imaginaries and you should be able to find them. There's an I in your answer, and hint, x squared plus 4 equals 0. Solve. There's 2 answers there. Total of 3 answers. Talk to the kid next to you about what you think the final answers are. Imaginaries and the real ones. Critical moment. A third of you, the first time we took a test on this, forgot the absolute value. Square root of 4 is 2, and the square root, I'm going to just break this into 2 square roots. I think that's the best way to show you what's going on. That's I, that's 2, hence 2I. And then why is there 2 answers, plus and minus? Because it's an absolute value. It could be 2I in here, or it could be negative 2I in there. So that's why we say x equals positive 2I and x equals negative 2I. And sure, at this moment, you could have just simplified to x equals plus and minus 2I. Do you get that's 2 imaginary answers? Yep. And 1 real answer. Now, some people get this confused. They think there's 3 x-intercepts. Because I said there's 3 answers, they think there's 3 x-intercepts. Nope. How many x-intercepts are there? Only 1. Because these aren't x-intercepts. You can't see them on the graph. They're imaginary. Just like leprechauns. You can't see them. Even if you know they're there. Hunting for the pot of gold. Can't see them. All right. Any other questions about that kind? Okay, so many things we got to practice, so I'm going to keep on going here. What if I just tell you some hints about a graph? Can you make the graph for me if I said it has a double root at 3? Well, right now you can't sketch it yet because you don't know enough. The lead coefficient is positive. Well, that helps. We know one of the ends then. And it has another root at -7, but it's not bouncing there. It's just passing through there. Make the graph. You know the x-intercepts. You know that it's the lead coefficient is positive, so you know the right end is going somewhere. You should be able to make the graph. Okay, well, I knew that it touched 3. I knew that it touched -7. I knew that lead coefficient is positive, means it's going up here. So here's my answer. You tell me if this is possibly right. Nope. Tell me one thing that's wrong about it. Jackson.
There are 3x-intercepts.
There are 3x-intercepts, and I only told you about 2 of them. That's one thing that's wrong with it. There's more that's wrong with it. Yes? It doesn't bounce. A double root is supposed to bounce. So, bounces and then goes through. Could that possibly be right? Yes, that could be right. Now, how about this? Did I ever tell you the y-intercept? What if I told you the y-intercept and it was like 5? Would that possibly make sense then? Good. Okay. All right. Do you want to do another one like that or not? A lot of nodding. Okay, let's try again. Let's say there's a triple root at 3 this time. I hope you know what that means. There's another root, which is the same as a 0, at -5. And the lead coefficient is negative. Make a sketch of that. Okay. Here's 3. I'm supposed to do a triple root. I guess I'll deal with that later. Then there's a -5. Lead coefficient's negative means it's going down on the right side. Are you with me so far? Okay. Now, how do you do a triple root? That's that weird kind of snaky thing. And I can't obviously draw it for you, but if you're like, how do I know if that thing is a triple root or just a regular pass through? Go back to this kind of a graph. Do you remember that deal where this is x to the 3rd? What does that look like? Well, it's got this inflection point in it where it changes from, as it goes from left to right, it's slowing down and then it speeds up. That's a triple root. I would have definitely given credit for my rendition of a triple root right there because it looks like, as you read from left to right, it looks like it's slowing down and then it speeds up its drop. Okay, it's about the change in the rate. All right, those are tricky to draw. But what'd be more important is that you recognize it. If you saw something like that, you'd have to go, oh, that's one of those triple roots. All right, and then it's got a root at -5, so I got to go through this, and then it's just a normal pass through there. And I should connect that up, and then there we go. Now I know the drawing of the triple root could cause stress. Just try to remember that it needs to change the speed that it's going. This one was slowing down because it was getting flatter and flatter, and then it went really fast. It's changed from slowing down to speeding up. All right, maybe it'll help if I draw one. There's a bounce. There's a pass through. Slowing down, all of a sudden speeding up. If that's at 5, going through the origin makes it obvious what that number is. And let's say this is -4. Can you give me the equation, like this kind of thing, for that? I'm going to pause for a second. This is probably one of the tougher ones and very important. Now, when we're done with all of this, there's a worksheet for today, which is a lot like the test. Would you agree that if I let you take the actual test home, and work on it tonight, that would be a monstrous advantage. The actual test. Wouldn't that be like, oh my gosh, that'd be insanely good? Well, it's pretty much the test. It's just that the numbers are different. Okay, so take this worksheet home. It's like I gave you the test early, and I'm even giving you the key for it. Now, there'll be some kids that'll be like, yeah, I'm too busy, I'm not doing that. Okay, fine. But you could have had a chance to see the actual test and all the answers to it, and you didn't use it? Especially on the hardest test of the year so far? Oh, please, do it tonight. Check it with the answer key. It'll be huge for some of you. Some of you have gotten like low B's lately, and all of a sudden the hardest test comes along. What do you think's going to happen? Unless you do something to change that fate. Okay, you got an equation for this? Check with the kid next to you, see if theirs and theirs have the same elements in it. Okay, let's see how you did. Did you even think about the fact that it's going up on the right? Raise your hand if you thought about that. Cool, then you win. If you didn't even think about that, you would have missed it if it was going down. There's no other way to know that there's a negative in front, right? This one does not have that, but if you didn't even look, then you lose. This one is positive in front. We don't have to have a plus there. It's just clearly not a minus there. Okay, next thing. It's triple rooting at 5. X minus 5 to the third. If on the test you're not sure with whether like is that one of those kind that's doing the weird squiggly thing, you can ask me. All right, so this spot right here, that's 0. And I had a kid ask, could I put x plus 0 or should I rather simplify that to just x? I would take both, but in math, you always want to make things as simple as you can. Would you agree that regular x is simpler than that? So regular x really should just be regular x there. And if you're going to have a regular x there, it really should just be in the front. We don't need a plus there. That makes it more complicated. Might as well just leave it and not have a plus and put the x in the front. And then the last spot we need is for that other root, which is at -4, so it's x plus 4. And, oh, it'd be so sad because the kid would get it wrong because they forgot it was bouncing there, so it's squared. All right, let's do one more like that. Write me an equation for this one. Boing. Eight, 3, -2. Now, there is a reasonable question in here that somebody should ask me. Is 3 an inflection point? Very good question. That's a really tough call. To me, it looks like it's just passing through. So I'm going to say that's not a triple root. But it was a good question. If it was like that, then I would have said, yeah, that's a triple root. But I don't think it is. So what's the equation for this one? Carter Mueller, tell me one of these factors that you know must be in there.
There's a double.
Okay, where?
-2.
So what should I put in for the factor for that?
X plus 2.
And what does the double mean?
Squared.
Squared, very good. That's a double. That's a single, but it was kind of close to a triple, but it for sure isn't an even root. I mean, it was either a 1 or a 3, and I told you that one was a 1. And then that's a single root also. Okay, so then I got x minus 3 and x minus 8. And this kid loses. You caught it? Because it's going down on the right. You had to have a negative in the front. Ouch, that would hurt. Okay, I maybe got that one right. Cool. One last hard factoring. And then really need to learn from the practice problems I've given you and the key. Okay, so here's the last question. X to the 6th plus 3x to the 5th minus 9x minus 27. Wait, I screwed up. My bad. Wait, one more thing. It was 6th, 5th. This is 4th. And this is 3rd. Sorry about that. Look at the end of your problem. It's x to the 6th, 3x to the 5th, negative 9x to the 4th, and negative 27x to the 3rd. Factor that. Now, some kids get so into the rational root theorem that they're like, oh, I'll do rational root on it. No. Not to start with. Always look for the GCF. After you've figured out what to do first, please check with the kid next to you just to see if you're doing the same first step as them.
Just go next to the third.
The job here is to just factor it all the way.
Oh.
All right, we're kind of running out of time, so I'm going to get this x to the 3rd factored out. And then I got x to the 3rd plus 3x squared minus 9x minus 27. And then, do you have to do the rational root thing? No. You could have, though. Did you even think about that? You could have done synthetic and done 1, 3, negative 9, negative 27. You could have done that. But in this case, it was smarter to just factor by grouping again. But did you notice the twist at the end? All right, so let's see if you did. X to the 3rd here, and then x squared comes out of the first two terms, and you have x plus 3, and minus 9 comes out of the next two terms, and you have x plus 3, and then that factors 2, because this is now the common factor. X plus 3 comes out, and then you have x squared minus 9. Did you even notice that that factored? It does, because if you left it that way, you got burned with the classic. You factored it, but you didn't factor it all the way. Final answer, x to the 3rd, x plus 3, and then this is two of them, x plus 3 and x minus 3, and yes, I would like it if you put these together, but it isn't required. This would have been an awesome answer. Anybody get to that before I said it? All right, about half of you. That was a hard problem. All right. Now, what if you hadn't, you're like trying to factor by grouping, but you can't? Then you have to do the deal where you pull out a number, you figure out what number using the rational root theorem, and you'd have to do synthetic to try to factor it. If this didn't factor by grouping, you'd have to use synthetic. And how would you know which things? You'd check 9 and 3, because their factors is 27, and 1 and 27, and plus and minus of all that. All right. That covers pretty much everything. I know it was a lot. And so some of you may want to actually go back and watch this video over again just to kind of hit the ones that you got wrong. Like when I gave you a practice problem, if you got it wrong, maybe you should go watch that part again. I'm warning you, tough test. So we're going to start it right on time tomorrow. Like nothing to warm up at all. Just you got to do all your warm up tonight. You got a practice test. You got the key for it. So be totally ready, because when you come tomorrow, I'm just going to flop that test on your desk, and you're going to do your best. All right. You can also ask me questions after this is done, which is not too many minutes, but you have a few minutes where you can ask me questions right now. And that's all I got for you for today.